showed before is just an introduction about the project. Is divided in different sectors and different demonstration cases, services and regions. We focus on the obviously flooding and emergency response in Malta, but we have also other case studies, for example, water management and agriculture supply in Andalusia that suffer a lot of droughts. And then we have energy planning in Lakatami and Cyprus. They are considering how to using the climate change projections to increase the efficiency of the energy system. And then for the Valencia case study, they are trying to improve the management of the port infrastructures and operation. I'd like to say that all these case studies are interconnected in the way here in Malta we are studying the flooding and emergency response, but obviously we can apply also the case study of the water management, also the case study of energy planning and the port infrastructures and operation. Maybe it's not going to be big infrastructures in Malta, but for sure you have a lot of touristics infrastructures and interconnection between Northern Africa and Italy for sure. So it could be interesting also to go deep in that sections. This is another slides that you have seen before, just to locate how it could be the prediction about climate weather in the future. Obviously, in now and today, and within 3 days, you have a normal meteorological information that you can easily find online and the television. Then we have on the year, decade, and century, you have climate projections up to the end of the century. And then we have this central part that is seasonal projections that are actually pretty interesting because you can use all this information to manage your sectors, your productions, your whatever you want that it's related to the data you have. You can manage, you can plan in these sectors in weeks, months. And actually, these data they are not available online in an easy way, I would say. Obviously, you can find these data, but you have to process this data. You have to download it, process, and then publish these data in the platform that we are giving you and showing you today. You will see that these data. So the seasonal data, obviously also the climate projection, but mostly the seasonal data are already elaborated, downloaded from the servers and uploaded to the platform and keep updated, so daily updated. So these data are I would say very important for governments. Could be very important for governments to make seasonal planning and also long-term planning. So going to the Malta case studies, what we have done for the island of Malta is to study the impact of coastal flood risk in the northeast coast of the Malta. And then we studied the pluvial flood risk or the flood risk coming from extreme rainfall events in the central part of the island, so involving the Valletta, involving this central part with Birkirkara, Quarmi, and Sida specifically. So just going to the points, as I said, we developed this pluvial and coastal flood risk assessment. What we've done is to develop a bathymetric sea level model for the coastal flood risk. So basically what we have done is to take the DTM of the island to put a bathymetric sea level all over the island and to increase this bathymetric level following the climate projection. And we can see interacting with the island where the water will arrive in, I don't know, 15 years or even more. While for the pluvial model, we are developing a 1D, 2D model The surface runoff. So imagine the rainfall coming to the highland and starting runoff all over the highland. And then we inserted also the 1D model, which is the drainage model of the highland you have, that it has been developed in the National Flood Relief Plan. And thanks to the George and his team, we received a lot of information of the drainage system that is actually it's a pillar of the drainage system of the island. So it was very important to model and add to our model. After that, after to have developed the flood risk maps, we're gonna develop. We're gonna quantify. We're gonna quantify the amount of area which is at risk for different scenarios. Make a distinction between the pedestrian and vehicles, because obviously a pedestrian will be much more affected compared to a vehicles, but a vehicles will generate much more damage, as we can see in some photos, specifically in the area of Gormi, where you have a drainage channel and all the cars hit into the channels and close the channels, and then the water goes outside. So we had a conversation with George and your team. This is quite typical there in the island. So it was interesting to model also these vehicles risk. And then we're gonna make an expected annual damage for different scenarios, or basically the quantification of the damage you could have every year if you do not do anything to change this risk. And then we're going to make for sure some proposal to decrease these expected annual damages. For example, to put barriers, to increment the drainage system, or making other solution that it could be suited locally. And last but not least, this point I'm not gonna share. We're gonna develop in the future because, as you know, we had a big cut in the budgets, but it could be very interesting for sure, which is the cascading effect analysis. What is that? Is considering that you have in the highland infrastructure where they are spread all over the highland, for example, police, electricity stations, you have hospitals, you have schools, as anybody. We are trying to interconnect this infrastructure, generating a cascading effect. For example, if I have a flood in a specific area and this flood affects me, the electricity administration of that part, then I could have problems also with transportation because lighters are not working, because police can have problems to manage the situation there, and also we can have no electricity in the hospital, even though we know that any hospital has a gasoline generator. But we are studying the stuff to see if we can propose you something interesting about this cascading effect analysis. What we are studying for the Malta, we're using as a referencer, as main references, the Stormwater Management Plan and the National Flood Relief Project. And then we have to look at any other documents, such as the Pluvial Flood Risk Assessment in 2 different years. And we have downloaded also information from a European project specific for the coastal flood risk. And then we have also interpelled Professor Gelis from Uni Malta to receive some rainfall information, but unfortunately, this connection seems lost. I don't know what's going to happen. So let's see. This is to explain a bit the coastal flood risk, the project that I showed you before, the List Coast project. This project studied all over the coast of Europe the impact of the increase of the sea level. For the highland of Malta, you have these boats. Actually, I don't know the name, but these points. We took the points P1 and P2 because they were closer to the area, to the study area, and we model. We calibrate our model following these 2 points. Regarding the pluvial model, we have using the DTM and meshing all the DTM and studying the surface runoff and the integration with the pluvial, the drainage system. but then this all part of the highland. So as you can imagine, the water fell in the left part and goes down to the right part, right upper part. Okay, so this, as you can imagine, you live there, so you know better than me for sure. As I said, we had also the drainage system, and Cormi, Birkirkara, adding also the inlets. So we have, what we have done is to model the system at inlet scale. So as you can see, we have different type of inlets, different type of catching system within the highland. And we model all the system, not actually the single grades, but we apply different functions to different inlets, so the model can better represent what you have in reality. Coming back here, I forgot about this part. We did not study this part. We just studied the Cormi, Birkirkara, and Zida. Obviously, we have the result for the whole island, but I think it's in the mark of the project to study just these three municipalities. This is the updates about the case study. Cost of flood risk, we have completed the model. Now we are developing the flood, the risk maps and the expected annual damages. We keep on going on that because it's quite tough task, because we have to find a good correlation between for example, the depth of the water and the damage that are generated in the houses, and then we have to calibrate the model. I mean, it's complicated, but we keep working on that, and I think for the next meeting we will have something to show you. Pluvial Flood Risk, we have completed the 1D 2D drainage model. For sure, George, thanks a lot for the information, and all the others that send us information. We are quite happy about the model, about the results. Now we have making some calibration using the aftermath photos that we have. And then we're going to make a flood map validation. The idea is to generate this map and then show it to you and identify some points, and basically ask to you, is that right that you have that floods, or it could be, I don't know, should we have to adjust the model? This is going to be done in, I think, in this month and in the next month. And then we're going to have the risk map development and the expected annual damages, which is the same thing for the cost of flood risk. We have to find a good correlation between the velocity, the depth, the water in the street, and the damage generated to the buildings. And then the cascading effect, as I said, should be, I don't know what's going to happen in the next month. But it could be a good point to develop, because, as I said, it's very interesting also for the municipality, for the government to make a planning, long-term planning also, and to see which infrastructure are the most affected, and which infrastructure are the critical ones that generated the most damages to the island. Go to the platform. This is what you can see. Cesar showed you something before regarding the case study of Malta. He is divided in 3 parts. We have the meteorology part, which is seasonal prediction up to 6 months, and we have two models here inside that I show you. Then we have the climatology part, which are the projection up to the end of the 21st century. And then we have the planning tool. Here the name is inundation, but it's actually the planning tool. We're working on that. We keep developing. It's not finishing yet. As I said, Cesar, we're quite sorry about that, because actually it was an opportunity to show you something, but we had problems in developing this task, because it's the most complex, and obviously you require much more time, and considering also that we have cut in the budget, the amount of hours dedicated to the development of this on this part of the platform is changing, but we are pretty sure that For the next meeting, general meeting, we will provide you a complete platform to test. Going to the single part and the meteorology, which is the seasonal prediction up to 6 months. We have these two models, the European Center Meteorology Weather Forecast, which are daily prediction, and then we have Copernicus, which are monthly prediction. Taking into account that these data are available online, but free available online. I'm not sure about this, but it's for sure because I use it. It's free. So you can go online and download it and treat it and use it as you want. But the main pillar of the platform is that you already have this data. So the platform go daily online and download this data, treat this data and charge into the platform. So you can see daily prediction and monthly prediction up to 6 months every day, updated every day, okay? And these data are, for example, temperature, humidity, precipitation, wind gust, wave height, and for the Copernicus rainfall precipitation, more or less the variables are always the same, but obviously the time scale is different. This is daily, this is monthly average, okay? And maybe for the Malta case study for the flood risk is not so, not interesting, but the only thing we are going to use for the flood risk, it could be the precipitation and maybe the wind gust for the coastal flood risk. But as it happened in the other case study, you can use all this data for protection application in energy, agriculture, and maritime transport sector. As I said, energy is happening in Lacatamia. They're studying how it could affect the energy production, and also the energy demand for conditioned air system. And Andalusia is studying the agricultural effects long term, and also seasonal effects, combining, I don't know, precipitation, temperature, and obviously humidity. And for the maritime transport, this is not maritime transport that happened in Valencia, but it could be useful to you because, as I said, you have a lot of touristic routes between Italy and also Northern Africa, I think. So taking into account this, because it seems like we just forget this part of the platform, but actually it's very important. These data, as I say, these data are available online, but you have to treat this data, okay? So the platform already treat this data and offer you this data, show you this data at daily basis, updated, something that actually I never seen online. I never seen in any other platform. I've seen the data, but never the platform, okay? So taking into account. And then you have the climatology, which are the projection up to 21st century, the end of the 21st century. I know this projection we have seen this projection for maybe all over the world and all over Europe also. So we know what's going to happen. That's not we hope, but we know what's going to happen in the next years. But it could be interesting, by the way, to have all this information in the platform, you know, to use it as a reference and to, you know, show taking into account to long-term planning, as I said before. And we have average climate and also extreme climate. Maybe the extreme climate is more interesting because you will give you the upper border of so the extreme events, basically. And then we have the planning tool. The planning tool is divided in different parts. The coastal and pluvial flood hazard maps that we developed with the pluvial and coastal model. So in the platform, we will have all these maps, flood and hazard map, historical and climate change scenarios. Then you will have the vulnerability maps for the vehicles and pedestrians. Then you have the risk map and the expected annual damages. And then we will be able to make a scenario comparison. And this, I don't know. But till now, we have completed just the first part, and how we'll see, actually it's not well completed, but you have something, we have something. And regarding this part, we don't have it yet. We are working on that. And as I said, for the next workshop, which it could be, I'm pretty sure it's going to be in September, as am I right? You will have the ability to see the platform, to test it, and to understand a bit more about this. The general workflow of the platform that you can use it, just to explain you a bit, is this one. So you have the flood maps that we generated with the coastal and pluvial model. And then you have the vulnerability and the vulnerability maps, which are these maps like here. Did I show it before? No, I'm sorry. Okay, so this map right here is the vulnerability maps. So you see the highland divided in different colors, green, red, and orange, depending on the amount of risk you have in that area. What it could be, you can modify these maps by drawing the polygons. Okay, for example, in this point that is red, I can say, okay, I'm with a project, I'm gonna to change the vulnerability of this area because I'm gonna put, for example, barriers against floods. Okay, so this area will become green or orange. So what I'm gonna do, I'm gonna develop this. I'm gonna draw the polygon all over the area and change the information of the polygons. So the polygon will become orange. And then in this workflow, you have another risk map. Okay, I don't know if I explain it in the right way. I'm trying to explain it a little bit. So you have the flood maps that we developed with the models. You combining with the vulnerability maps and the damage curves that related the depth with the damage. And then you obtain a risk map, identifying which area are the most problematic, and then the expected annual damage and millions of euros per year, or depending about the damage. In that way, you will see in the highland which are the area which are the most problematic areas. And then you can, as I say, change the vulnerability for pedestrian or for vehicles also, doesn't matter. And then reevaluate these risk maps and reevaluate the expected annual damages. So this workflow lets you to make a long-term planning, also yearly planning, for example, to evaluate the different solution, as I say, to, for example, change in this area or maybe acting here because we have much more damages. So the idea is, so for example, to put a barrier here, so this area will change. I mean, it's up to you. It's up to the decision you will make. But this should be the workflow of the platform for the Malta case study. And then I would like to show you a bit the platform, even Cesar made it before. Okay. Okay, so again, I'm sorry for the language. It was supposed to be in English, but actually in Spanish. You have meteorology here, the Copernicus and the European, climatology, extreme and average climate, and inundation, that this should be the planning tool for coastal and pluvial. And then you have an extra section here for the helps and anything you need to explain a bit the platform. I'm sorry. I hope this is not gonna happen, but it seems like we have problems with the platform. I hope it's not because many people are inside right now. It's gonna be quite ridiculous that it happened. I'm sorry, yeah? Just a sec. I think they didn't take it into account that too many people connected to the platform at the same way would create problems. I hope not, but it seems like we have problems. Obviously, the platform is much more responsive than it is right now. Okay, it's working. It's working. It is time, but it's working. So this is the Copernicus. As you can see, you have monthly. Okay, monthly prediction. You can move here within this time scale. Just clicking at the next month and then the next month and then the next month, moving like this. Consider that the prediction is going up to, I mean, 6 months, one here. Not sure I had to ask to Cesar, but obviously if you go to September 2022, for example, you don't have any data because simply the model of the Copernicus didn't develop yet any prediction. So to show you a little bit, for example, if you want to see the precipitation anomalies for the month of May, as we can see, you won't have any anomalies this month. Maybe in June or in July, seems like something there. Or in August. In August, seems you will have a small decrease, well, in the upper part, but it won't affect the highland. This is, for example, the precipitation temperature. You won't have, well, in the southern part of the highland, it seems like you will have an increase a bit of 1 degree compared to the average. Very important. Any point you click, it gives you the information that you are showing here. Okay, so any point of the highland you click, they give you the information. Okay, you see the precipitation, and then you have the maximum temperature, and you see how it could be the path in the future. Okay, so basically this is Copernicus. It's to prediction by month, and then you will have the European, which is the other, which is as daily prediction. As you can see, you see days instead of month. And the same happened here. You have more or less, actually not the same variables, but similar. And obviously the time scale is different. And you can see, you click on a point and you see how it's going to be the variation of these variables in these days, for example, between 10 of May up to 16 of May. Okay, more or less, you have good weather as always. You have in Malta, guys. And I think this is this problem. And then we can go to climatology. You have average climate and extreme climate, and here you have decades. You have the upper limits, how to say, the projection up to 2021, 2046, and 2071, I'm sorry. And you can change the scenarios, lower, medium, upper. Okay, for example, if we are showing this is the temperature, maximum temperature, okay, for the highland, the worst case scenarios, which is upper 2071. You will have more or less, actually here in the mountain it's cooler, but it seems like you have between 20, 30, 35 degrees. Or you will take information also about the number of days with the temperature greater than 38 degrees. And it seems like in the worst case scenarios, you will have less than 5 days. So that's good. You will have less than here in Barcelona. And the extreme climate is the same of the average climate, but with obviously the extreme variables. And then going to the last part, you will have the planning tool. As you can see here, we have uploaded already some maps. This you can show right now is the coastal flood risk historical for 5 years certain period. So you can basically change a number. As you can see, the period is changing. and obviously change also the information. And as I said before, whenever you click in the maps, you will have information. For example, here in this beautiful plaza, with you do period of 1000 here, you will have 0.5 centimeters, no, actually 50 centimeters of water in this part. And then if we could see the upper part 1000, it seems like a disaster. I mean, you will have 1 meter here in this part, you will have 62 centimeters here. The water can come up to this point, you have 50 centimeters here. Well, just to, you know, you can use this platform, you can use these maps to taking into account which area are the most affected and work directly in those areas to obviously decrease this hazard and to decrease this vulnerability, of that area. This is just the coastal. Obviously, we miss the part of vulnerability and holds the other part. For the fluvial, actually it's pluvial, not fluvial. This is a kind of an example of how it could be the vulnerability. Here you see the streets, okay? So you can select the single street and you can take up information of the street. Obviously, all this information will be uploaded with the name of the street and the currently vulnerability, but you can see all the information, okay? And the idea is to, if you want to change the vulnerability, to click on the, for example, the street and go here and insert some information. Obviously here it will be different. You can change the type of road, if it's open to vehicles, if it is closed, if you have a particular protection, protections, I'm sorry. And obviously the color will change. Now it's the default, which is violet, but it should be another color. And I'm not gonna show you the maps because, as you can see, we have errors here in the how to view it. So it's useless to show you this. Don't take it into account this simulation. We have it, but obviously the visualization is wrong. And that's it, more or less. This is the platform. As I said, I'm sorry about that we missed this part, which is the main part actually. As I say, due to the cutting of the budget we have and problematics we have, we are developing this part. It's not ready yet, but it will be in the next month. I like to pinpoint this part about meteorology, which is personally I consider very interesting. Well, the climatology, as I said, is we already know what's going to happen in the next year, but about meteorology, we don't know anything what's going to happen in the next 6 months and in the next week and in the next month. So these data are personally, I consider this awesome because, as I say, they are online, but you have to download it and treat it, and they are not uploaded, they are not updated. So this platform gives you the possibility to consult these data on daily basis and uses to make long-term seasonal planning. I'm sorry, to make seasonal planning for agriculture, energy, transportations, a bit of flood risk also, but it's harder because we are not sure that it's gonna rain in the next days, in the next weeks, but actually we can predict what's going to happen in terms of temperatures, in terms of maximum winds, all these variables.